So animations made easy. We're going to talk about the different tools that are a part of the SolidWorks suite of products, but we're going to focus on the tools that everyone has on their desktop in animation. Before we get started, I have a few polls or questions back to you about why this session might be popular or important to you. Okay, first poll here. I want to find out of the group that we have on, how many of you are on here because you are required to create some sort of animation from your SolidWorks models and are just trying to get an idea of where the tools sit. Maybe some of you are here just kind of fact-finding and learning what tools are available. Just want to get kind of a cross-section of what we have here. I'll go ahead and close that and show you the results just to give you an idea of the individuals that we have on here. So most of you looks like are going to have to create this type of content. Now, for those of you who are creating the content, the animations, what areas of the business are you being tasked with creating the content for? There's lots of different areas in which you could use the content. It can help you in marketing and sales and just general communication with the manufacturing floor. So this will give us a kind of a sense of where everyone is focusing their efforts here. Give you another second to vote here. And this is great because it looks like everyone's kind of all over the map, and it's great because 3D models can be utilized really in any part of the business. So it's great that these are going to be used not just in engineering but all over the place within the business. And last one here. This is more specific to the tools inside of SolidWorks, and don't be concerned if you're not aware of the terminology. That's why we're here today. But have you used any of the following motion study types? Hey, if you've never heard of them, you probably never used them. So just give me an idea of those who have kind of stepped in and utilized some of the tools. Okay, I'll give a few more seconds here. All right, let's share that. So we have again a broad cross section. Those using animation and basic motion versus motion analysis. I'm going to clear up and focus on specifically the animation portion of the software today. So that's where we're going to focus. I want to just kind of clear up, how it's utilized, the kind of things you look for. So our agenda is this, what is the SolidWorks Motion Manager? Let's go through the interface and understand how we use it. I want to talk about the different motion study types that I just polled you on. And then I want to kind of come back and forth between the next three things. First one is to understand when we decide which study type we want to use and how we make that decision. Talk about what the colors mean within the software. That's important to understand because this portion of the software relies a lot on colors for an understanding of what's really going on once you do set these things up. And then we're going to go through 6 or 7 examples illustrating how we animate a bunch of things within the software. The first topic we need to get out of the way is the Motion Manager. The Motion Manager is kind of like the add-in. Now, for those of you who have been around SolidWorks for a while, there used to be a SolidWorks Animator product, and that has kind of embedded itself in the recent releases directly inside of SolidWorks so that you don't have to turn on this Animator tool. What we do have to turn on, however, is the Motion Manager. So I'm going to show you how to do that. Now the Motion Manager, we're going to go through the interface, but it contains 3 or 4 things that are very important. One being this idea of a timeline. It's an interface, a time-based interface where we focus on what happens to things within a period of time within the software. We're also going to introduce first thing here a tool called the Animation Wizard to give you some real quick quick animations based on some things that you've already done. We're going to spend a lot of time talking about the Motion Manager design tree, very much like the SolidWorks Feature Manager design tree. It's everything that we have related to the motion and the animations that we're creating within that, including the assembly components and the sequence of the assembly. And then we're going to talk about the outputs, the ability to create AVIs or a series of images upon the output. Now, the other thing we have to understand, and my poll question kind of brought that up, is what are the different motion study types? I mentioned animation, basic motion, and motion analysis. Well, animation, we focus specifically on just changing positions in time. We do handle and understand the interaction between mates and something we call motion drivers, or the ability to add motors. We're going to show you that a little bit later. Now, jumping up the next level, basic motion, you're going to use features from animation, but you're also going to add some physics to it. Things like gravity and springs get added directly to it. That will require you to use the basic motion study type. Now, if you want to get into full-blown motion analysis using SolidWorks Motion, where you can, size motors and cylinders and look at accelerations and all sorts of different things and actually analyze the forces behind some of these things. That's where SolidWorks Motion comes into play, so you'll have to have a seat of premium. Today, again, we're focusing on animation and the basics of setting up and working within the Motion Manager inside of SolidWorks. When we talk about animation study type, we talk about what can we actually animate. Well, we animate things like the component position, component properties. Those properties could be, is it hidden line, visible, hidden, remove? Is it transparent, hidden, or shown? Colors, appearances. And then we animate the viewpoints, how we're looking at the model as it's going through this. Now, a little disclaimer on here, just so we're all on the same page here. None of the motion products are intended to animate non-mechanical systems, human movement or movie effects, things exploding and, that kind of thing. It's not meant for that. It's more mechanical systems and how those work. Now, why do people create animations? I mean, why not just, build the machine and or equipment and go out and grab your video camera or your cell phone and take a video? Well, first thing, maybe that item does not exist, right? So you can't just go out and take the video. But it really comes down to the effects that you can't achieve in this physical world. You can't make parts move through space without attaching them to a fixture to make them move. Make parts accelerate, then disappear. Parts that are solid can't move through each other. You can't make things transparent and see what's in or behind them. So that's the reason a lot of people focus on an animation type tool to show unique things about the products that they design. Another note about the animator and all the tools that we provide, rigid body motion. The animation will not allow components to deform. I put the picture of Silly Putty up here because that's what I'm thinking about. If you push a part into another part, it's not going to, like the deform tool in SolidWorks, it's not going to deform like that. However, I'm going to show you today how we can use animation techniques that will allow components to change size or shape. Okay, so it's not a dynamic deformation. It's more using the SolidWorks software to make that happen. Now, there's different types of motion, which we're also going to mention today. Free motion is when you're not thinking about mass or boundaries or how parts interact with each other. You're basically going from one location to the other, very, very similar to this. Just two parts, they go directly through each other without a problem. They have no relative idea that the other exists. The other one would be kinematic motion, where you're actually in SolidWorks, you've spent all the time setting up the mates and the connections between components, and you're going to animate the kinematics of what you've already done. You've probably seen this in the training class, the SARS mechanism that animates through and drives this. We're going to use that a little bit today as well. And then you go a little bit further, which is starting to get into the dynamics. When you start to add other conditions, forces and gravity and springs, you get into more of a dynamic nature. Things are dependent on position and size and the forces that are applied to them. You've probably seen this one as well some point along the way. So with all these things said, we use the different types of motion to start to distinguish between the type of motion study to use. Now, because we're focusing on animation today, animation can do all your free motion, where I showed the two solids kind of interacting or going into each other, or kinematics, dealing with the mates of components and actually moving them mechanically. But anytime you get into dynamics, you're almost automatically going to jump to basic motion and the SolidWorks motion product. And I will show how those are there, but we're not going to focus on them today. We're going to talk about this concept of driving motion today as well. What drives that motion is just as important to help you decide which of the study types that you're going to utilize. If you're dragging components point to point, or you're driving using mates or motors, that's where the animation study type is going to come into play. But if you add things like gravity, contact, and springs, as you can see there, you have to go up to basic motion. And then you get even further with forces and dampers, you're going to use the SolidWorks motion product. So sometimes those things overlap, and you might require a motor with a force. That's where you would kind of jump up to that next level. Now this next slide is going to kind of freak some people out for a moment, but we're going to come back to it quite a bit. This is taken directly out of the help menu. And if you're going to be tasked with doing animations, I would suggest you take this and do a snip directly out of Windows and print this thing out and put it on your desk. We're going to go back and forth to this throughout my animations today, just so we have a clear understanding of what everything means. Within the motion study types, the colors of items within the system play such a huge role in understanding of what's really going on. Otherwise, it just looks like a jumbled mess, and you'll never have an idea of how to make changes and to get things going. So I will be definitely coming back to this, so don't worry at this point as to what's going on. We're going to kind of flip over to SolidWorks for a moment here. So in SolidWorks, how do we get to the motion manager? Some of you may or may not already have it within your interface, but if you go to Tools, Customize, what you're looking for under your toolbars is a toolbar called the Motion Manager. Once turned on, you will get a single tab or a series of tabs depending on if any animations have been created already. Now, the important part is once we get into these tabs, we need to understand the Motion Manager and all the areas within it. First things first is this pull-down menu off to the left-hand side. This is what we've been talking about since I started, of what study type do I have to use? Well, you have three choices. Now, some of you may only have two, but three total choices: animation, which we talked about, basic motion, and motion analysis. If you don't have motion analysis, that just means that you don't have SolidWorks motion and you don't have it turned on. Okay, so don't be alarmed if you don't see motion analysis. Now, let's just kind of work our way through the interface a little bit further. These are tools to play, stop, kind of like VCR controls, and to calculate the motion that you created. We do have a little slider bar here that allows us to drag through the motion. You can see in my graphics area it does change up where we are within the timeline. We can control the play speed by speeding it up and slowing it down here. Recording and saving animations. These tools here start to add in other items that are going to kind of get us into basic motion, things like springs and dampers. These things aren't utilized as much in animation. The one we're going to focus on today is motors, which we'll introduce a little bit later on. Now, the important part here is the tree off to the left-hand side. The tree mimics what you have in your SolidWorks assembly, including any sub-assemblies. It can be dragged out, and you can kind of scroll up and down within the tree. Now, under each component, if I expand the component, it organizes the things that we can animate kind of in these folders. We have the ability to move components, explode components. We can change appearances. We can also affect the mates within them. And remember I mentioned about colors. You can see off to the right hand side how much the colors and the interface plays a role into what you're really understanding here. So let's kind of move to that for a moment. Now, these little diamond looking structures are called key points. What they do is they control these settings that we can change for each of the components. So when I mouse over, and this happens to be the main jaw key point, it will show me if I've done any modification to any of either the move, the explode, the appearance, or the component properties. Now let's find one that has been modified. If I go down here to, let's see, let's do this appearance right here. So this one right here is showing me a little bit, this is something we'll introduce later, has been modified. Well, this little pop-up, we'll go through it a little further, but this pop-up is going to give me an indication as to what's physically changed. Now, notice the color of the key points also plays a role. We're going to talk about that as well. Now, this little bar that connects the key points is something they call the change bar. Now, the color of the change bar gives you a good indication as to what's being changed. For instance, this purple type color, or pink, purple, whatever you want to call it, lets me know that something in the appearance is changing. Now, if I happen to go to that particular part and expand it, you can see it now creates and has those three folders that we talked about before, and you can see under appearance that's that same bar. It's showing you that the appearance of that particular part is changing between the 0 and the 10-second mark. Now, how would I go about checking on that? You can see, we showed earlier, we can drag this little bar to a particular spot in time using the top slider here, or we can just grab the time bar and go directly to that point in time. Okay. If we mouse over the little key point, here's a good example. The appearance is changing color from one color to another. The transparency, it's actually being hidden. A bunch of things are changing in there, but the colors is what's important here. So let's just flip back to my PowerPoint for a second. I just want to bring this up. This appearance change, the change bar is going to be pink. If we're actually driving components, it's going to be green. So this is what I'm talking about with the colors. We're really focusing on what's changing based upon what's there. We're going to create some things from scratch to kind of help that out. A couple other things that we want to talk about. The tabs at the bottom, they can be renamed. You can duplicate or copy them. If you want to create a new one, you just create a new motion study and go ahead and rename it there. Okay, if you want help on this, definitely the knowledge base in SolidWorks is important. The help file is fantastic for motion as well. So that'll be important to kind of learn the system as we go forward. So let's start out with our first example. We're going to start out with maybe a concept that you've utilized already. We have the ability in SolidWorks, right, to go ahead and create an animation. The animation that we create now can be done through exploded views. So if I decide I want to explode this thing out, right, I can go ahead and start to drag this, and each step is captured. We know that that happens, right? And when I decide that I'm completed with this, the software in SolidWorks gives us the ability to animate the collapse or the explode of this. Now when I animate the collapse, one thing you may have noticed about this type of animation is it's limited in time. You always only have 4 seconds worth of animation. So what happens if I decide to edit the explode and now I want to move this particular part much further distance? Well, it's got to fit that motion into the 4-second window. So now when I animate the collapse, it's got to move that component much faster because it's only got 4 seconds to complete this motion. So that's where the animation part of the motion study comes into play. But how can we start this off by utilizing something that we've already done? So the first thing I'm going to introduce is called the animation wizard. And it does just that. It utilizes some predefined things to create an animation. It's found in the toolbar for the motion study, and it's wizard based, hence the name. So first thing I might want to do is rotate the model. Okay, I can tell it which axis I want to rotate the model, X or Y. I can tell it the number of revolutions. We can go 2 revolutions. Now how quickly do I want the model to rotate? Let's say 4 seconds, and it starts at 0. And when I hit finish, the software is going to go ahead and do that motion creation for us. Now, you'll notice that key points were created under the header for orientation and camera views. Each of these key points represents a position that it needs to be in. Okay. The time bar at the top just represents the total length and time for your animation. I can drag this out and set the length to any time I want. But let's go ahead and play this just to see what we got. This button here is a play from start, and you can see it's just kind of spun my model around along an axis to give me what I'm looking for. Now the other part of this in the animation wizard is to take advantage of the explode. If I decide I want to then explode this model, I can once again now add it to my timeline. Well, maybe I want a 8-second explode instead of the default 4 that was there, and I want it to start at the 4 seconds. So when I finish that, notice that it puts a bunch of the change bars into the timeline. Now, the orange colored change bar is one that just says, hey, this is created using an explode. Now, if I go to a point in time, this happens to be right around the 5-second mark, and I look at the nozzle. This is the point in which the nozzle starts to explode. So it clearly corresponds with a point in time with the change bar, 5.33 seconds, in which that's going to go ahead and move. So one of my suggestions here is to try to take advantage of exploded views to get you started on some of your motion that you're looking at. Another thing within this interface that I wanted to point out, you'll notice that some of these are kind of gray. This is letting you know that something underneath of this subassembly has been animated. If I expand that out a little bit, you'll notice that the pull ring, which is part of the subassembly, actually has the change bar, but when it's collapsed, it just shows you, it's like saying like a folder has something underneath it. So we can clearly use this to distinguish how and when things are changing along the way. And let's just play this from scratch just so you have a sense here. So the first thing you can take from this is the animation wizard and the ability to utilize the animation wizard to kind of get started. Let's take the next step here. What if I wanted to utilize the fact that I've already set up a bunch of mates to be able to show motion? Now it's pretty clear in this particular assembly that, and everyone's seen this from training, I can drag this thing 360 degrees and it's going to work. But how do I do this within the animation? Now, I don't really know exactly what's driving, how I'm going to drive it, except I know I can drag it in the graphics area. Well, I'm going to do it the wrong way to start with. Let's drag this thing to 6 seconds. And let's say I wanted to go a full 360 degrees. As I'm dragging this around, the software is going to automatically capture the key points because I've moved the bar ahead of time. Now the reason it does this is this tool called Auto Key. What it does is it captures what you've done dynamically. So if you move a view or you move a component, it captures the fact that you have just done that. Now, for those of you who may be new to this may be a little bit scary because you don't want to be just dragging things on the model and have it change your animation. So you may want to turn that off. But in this particular case, dragging that automatically created the motion that I'm looking for. Now let's just look at the time bar, the change bars for a moment, so we understand what just got created. It shows me a change bar for the crank that's green, and if I jump back to my little chart here, you can see that green means there's a driving motion on the subassembly. Okay, so we have a driving motion there. That's understandable. Now notice on the mates folder, there's this long brown bar, kind of thick. If I expand the mates, every one of the mates has this long brown bar. Now, mates are considered a feature in animation. When the brown bar is there, what that means is that the mate is on. It's being solved all along the way. Now, that being said, during animation, we can actually turn mates off. So we can turn mates on and off to make certain things happen. And it's done just by suppressing them. But the color coding is really just telling me that it's on. Okay, so we have a driving motion. This thin line just tells me the duration of the animation. Now, on the bottom right-hand corner, there's a couple things. There's a zoom to fit function. There's also a zoom in and zoom out. You can try those kind of on your own. But that's going to help you if you got a really busy animation look at certain things. But let's play this and see what just happened. If I say play from start, something funny kind of happened here. It actually went the other direction. Now the problem here is the software's trying to interpolate between the first point and the second point that you've provided. And what it's always going to try to do is find the shortest path. It still has to have and solve all the mates, but it finds the shortest path. Well, how do we get that thing to move 360 degrees? Well, here's what you might do. I want to make sure my auto key is on, and I'm just going to move this maybe 45 degrees. Okay, all my bars that we would typically have get created. I get a key created at 2 seconds. Now I can go to 4 seconds. And at 4 seconds, I can drag it another 45 degrees. And I can continue my way around until I reach my 8-second mark. Now, each time I got captured, I got a key point for that crank showing me that I'm driving the motion and I'm driving the position at each of those. Now notice as I mouse over the key point, for those of you who use SolidWorks all the time, you know what that symbol means. That's a move. You performed a move of the component at that key point. So use these tooltips to help you figure out what you've already done. Okay, if I look at the rest of the animation, these yellow lines with the kind of like the green outline, let's go back to my PowerPoint for a moment. If I look at the yellow, it means it's driven. We know the term driven in SolidWorks it's something that's kind of moving because of something else. Now there's two driven types. If the yellow is in the center, it's actually moving. If there's no yellow in the center, there's no motion. Again, using this key here is important so you can understand what's going on. So back to this for a moment. So let's just play this. See what we got. Okay, and we should get a full 360 degrees of rotation. So you want to be careful when you're capturing motion just by dragging components, because it's going to interpolate what it thinks is the best. Now let's go back to my dart gun for a minute, because one of the great things about this timeline is the ability to go ahead and modify the timeline. If I drag my little slider bar here, we can see there's a point in which the plungers start to explode, but they explode at different times, right? Well, the plungers are both part of the plunger assembly. There's one here. Let's see. Yeah, there's one there, which starts exactly at that point, and then there's another plunger assembly where another one starts here. Okay, you can see that there are different times. What you can do here is grab these key points and drag them in the timeline to adjust where and when you want things to start. So even though I've created my explode, I've now just set this up so my two plungers now move at the same time just by adjusting the timeline. Now another thing that you have the ability to do, if you select both key points on either end of a time bar, you can right-click on that and actually reverse the path. So you make the software, the plunger is now outside the explode, and then it comes back together at that point. So you can use these key points to do a lot of different things, like flipping and so on. Now another aspect to this is how the software interpolates between different things. How fast it moves. Does it speed up at the beginning and then slow down at the end? Now if I right click on any key point between a change bar, and I'm going to kind of move this out just a little bit farther so we can get a sense of this. But if you right click on the key point, there's a couple things here. We can edit the time this way instead of dragging it. But there's this thing called interpolation mode. Interpolation mode helps you to change how quickly it goes from one key point to the other over that change bar. Now the best way I have to illustrate this is another assembly. Now these are all moving from one end of this sketch to the other end of the sketch the exact same way with the same kind of motion. But each of them has a different interpolation. I think that's, yeah, they're in here somewhere. Interpolation modes. Well, the interpolation on each of these, one's set for snap, one's ease in, one's ease out, and one's ease in, ease out. And let me just play you this and show you, even though they're going the same spot, they're all going to do something a little bit slower or faster depending on how the interpolation is set. Okay, so you can use this interpolation mode to adjust how quickly things happen, even between these change bars. You can see that the top one snapped in place. It waited till the very end, and then it just showed up where you want it to be based upon the time bar. It's the same motion, but we control how quickly it gets there using these interpolation modes. Okay, so that's very easy to set those. If you just right-click any of the key points at the end of the change bar, you can go ahead and set these to things like ease in, ease out, and then you will see the difference in how quickly it gets there based upon your existing settings. Okay. On to a few other things here. One of the other things that we can animate is our view orientations. View orientations meaning how we're looking at the assembly. Now, from what I've already been showing, we know that if we have our auto key on and we drag the time bar to a certain spot, it will auto create what I'm doing. So if I drag it or move the assembly, it should auto create it. But watch this. Let's go ahead and just rotate the assembly. Nothing got created automatically all of a sudden. Okay, I expected it to show that view change. Well, what if I use my tools within SolidWorks or my views? Nothing's happening here. And most of you have probably seen this if you've attempted animations. There's a folder, just like there is for components, for animating the orientation or the camera views on the assembly. So if we go back to the beginning here, it automatically takes me right back to the original orientation. In order to auto capture the orientations, there's a couple things I can do. If I right-click that folder, I can turn off Disable View Key Creation. So by default, the system doesn't automatically update the view keys within animation. Now when that's off, let's say I go to 6 seconds, now I can use any of the other tools that I have, whether it's be my triad, my views, to position the components how I want them to be viewed. And I'm just going to rotate this thing out, pan and zoom a little bit. You'll notice that it got created at the bottom. I now have another key at 6 seconds. Now, if I happen to move this any more, it's going to update that key. So you have to be careful. So what you want to do is set the keys and then disable the view creation. And now what I've just done is I've just created an animation going from one view to another very easily. Now, if the orientation and camera views are locked so the auto key does not create it, here's one thing you can do. You can take a key and make a copy of it. So I can go maybe to the 10-second mark, right-click there, and paste. Now, once I paste the key, I want to set the orientation. And I can do that either by going to the slider bar, turning off the lock, and making the change, or if you click on the key, notice what's in here, the ability to change the view orientation. Maybe I now want it to go to a top view. Notice now there's a change bar between the previous view and the new view, and if I animate this through, I'm now going from the isometric to kind of that side orientation, and then it will rotate on through to a top view. Okay? So you want to be careful when you get started as far as orientation and cameras. You want to make sure that you turn this on or off. Now sometimes you create a bunch of camera views and you don't want it to play in the animation. You can actually disable the playback of those. Now when I play it, everything stays in the final orientation or the original orientation. Okay? So lots of things to think about when you get into changing the orientation. So let's turn that back on here for a moment. Now, next piece that we talk about animating is appearances and properties. When I talk about appearances and properties, I'm talking about whether the component's hidden or shown, whether the component's transparent, whether it's isolated. Maybe you have a large assembly and you only want to show a single component. You can use the isolate command. You can change the component display, hidden removed, hidden visible, or the appearances. When I talk appearances, I'm talking color, specularity, shininess, all those things that we deal with in appearances. The great thing is that's all done the same way as we've been talking about. So let's say we wanted to go to a certain point in my change bar, let's say at the 6-second mark. And at 6 seconds, I wanted this housing, or the holder here, to go transparent. Well, if I select the housing, I want to go down in the animation tree. I want to do all this work through the animation tree, by the way. All right, so let's see here. This is There's my holder. Now if I expand my holder, remember we have these these subfolders within this. I can go ahead and right-click on the appearance. I can right-click on the component. Here's where I can isolate it. Here's where I can hide it. Here's where I can change the component display. So let's make this thing hide at that point in time. Oh, did I move it back? Okay, that was hidden. So let's go ahead and show that. I want to make sure my time bar is where I want it. So let's go to the 6-second mark, and that's when I want it to hide. So now if you look here, I now have a change bar that's pink. And just for reference, once again, a pink change bar means I've changed the appearance on a component. So change the appearance. If I mouse over one of the items, you can see that my transparency is set to 100%. So it's 100% transparent. But if I drag the time bar, you can see it slowly goes from one to the other over that 6-second period. Now if I change my interpolation mode, like we've been talking about, I can make it snap to be transparent. So it'll be solid the whole distance until it gets to that point, and then it will snap and disappear. So this is what I mean by using these key points and the change bars with interpolation to make things happen on your time frame. Now, let's say at the 10-second mark, I wanted to turn the blue component into a different color. Let's see if I can get my slider here to jump up. All right, so there's my clip. We'll make the swivel change. So I would go to my appearance, and now I can control all these properties within appearance. Let's say I wanted to make this red. And within the red, I can go to the Advanced tab and now start to control other things like the illumination, maybe the transparency amount, how bright it is. I'm going to make it brighter at 10 seconds. Now it captures that change of appearance with a change bar, and now I can gradually see the change in color from one point being blue and the other point being gray to red. Hopefully this is coming okay across the GoToMeeting. If I want to change the time that happens, I just grab the key point, and maybe I want it to happen at the 6-second mark. So now that speed in which it changes colors happens based upon what I've specified with my key points. So what I want you to take away from there is with animation, we can animate the colors, properties, hiding, showing, transparency, component display. Now I did mention when we were talking about the different types and the ability to use animation at the beginning that we can also specify some driving components or driving motors, and that's acceptable to use within the animation tool. So an example of that would be this fan. If I look at how it's mated together, you can see that the fan can rotate on its base and the blades can rotate. But we want to show how this fan physically oscillates. So how would we do that? Well, we could create a time-based animation where it rotates, and we set up all the key points, or we could use something I'm going to introduce now, which is the motors. So we could go to a point in time, let's say the 6-second mark, and I could specify, you know what, I want a motor. I want a motor that's going to rotate the fan blades. So we're going to rotate this fan blade. What is the speed that we want to rotate? Let's say 600 RPM. And you can see that it's now created a rotation here, but as I drag through, nothing's physically moving. Let's just see. Let's rewind it here. if I go ahead and hit the calculate button, now that I'm adding a motor, I want to calculate the motion. It's a little bit different. When we calculate the motion, it's going to physically give me what I'm looking for, and I'm able to see the fan moving at that time frame at the rotation speed. If I want it to go 6 seconds, I just drag the time bar and I recalculate so it can complete the motion. Okay, now if we remember our colors here, we now have a rotary motor in the motion manager tree, and it's brown, meaning that feature is on. Okay, now we do have the ability to turn that feature off as well by suppressing it. So I can go to a point in time and actually turn it off. Okay, so that bar would disappear. Okay, so we have our motion that we're looking for the first one. Now, how can I get a little bit more advanced with this? Well, with the motor, we can create a rotary motor for the base, and we want it to move relative to this surface. But instead of a constant speed, we have different ways that we can specify the motion. We want this thing to oscillate. The total range of motion is 135 degrees, and then we set the frequency of the motion. And again, if I recalculate this, and not sure why it's not moving, but I should get an oscillation. Rotary 2, let's just go in there and edit that, make sure I got everything. Edge of fan, component. All right, that looks good. My motor, why this one isn't calculating. I'm just going to suppress maybe this one. Let's just see if one's affecting the other. There we go. So you can see now, well, that one's going completely her. There's my 135 degrees. So my frequency wasn't quite short enough, but you can see I started to rotate back the one direction. So these motors, you can do a little bit more with these motors, which is pretty neat to make things kind of move for you instead of you having to interpolate between them. Now the last thing I want to talk about before we close is one of the things I mentioned with the ability of components or the inability of components to be able to deform. So some people want to see things that dynamically happen, components stretching, springs working, and because we don't have the ability to deform, that can be somewhat tough. We're not changing the geometry of parts by deforming them. However, using some other techniques, we can make some other things happen. For instance, here's you've probably seen these models before as well, kind of a foam shooter of some sort. Now, if I drag out this particular plunger, okay, you can see that this little rubber band type thing doesn't update. However, if I do a rebuild in SolidWorks, it does update. Well, I want my motion, my animation, to show that plunger pulling back, which looks like stretching that band, and when I let go, it goes back to its position and launches the plunger. Now we're going to do that on the bottom half. So let's create our band first of all, so we have an understanding of how we might do this. Let's go ahead and kind of look at this from a top view. First thing I'm going to do is insert a new component which represents this other band. I'll just throw this somewhere on my machine, and I want to draw this in place on the top plane of the assembly. Now first thing I want to do is take advantage of symmetry in this case. Okay, we'll go ahead and draw what we need using some temporary axes here. Okay, this thing's going to come off this temporary axis. Let's see here. All right, come off this temporary axis, and it's going to just angle in and come back to the center here. Okay, we'll go ahead and lock this down by just creating some relations. Most of you have bend through this part of it. As far as distances, I'll control maybe a distance from the edge here. Let's make this 2. And I want the band to just come and touch the outside here. So now I've got this kind of locked down. Let's go ahead and add some fillets in here. And we're going to make those 2.5 millimeter fillets from both sides. And this is just telling me that I'm changing up my symmetry. We'll put some there, put one there, and go ahead and accept it. So I've created, what essentially is the part inside the assembly for my band. Let's go ahead and just open this component for a moment and create the sweep that we're looking for. And that can be just done on the right plane. We'll create a circular sweep, giving it a 2 millimeter dimension. And most of you should have been through this before. We'll sweep that. And this is my sketch, and so on. Okay, I won't finish this off, but you get the idea of what we're looking at here. So we've created this now inside the assembly. And I want to animate the fact that this is changing here. Let's change the color as well. All right, something a little more gray. Turn off our axes. So now if I go ahead and move this, if I control Q, it updates. Well, the great thing about a motion study when you capture that type of thing is that it does the rebuild at each time step. So now I can come in here at the 4-second mark and I can drag the plunger out. Okay, notice the pull ring has the driving motion, but you don't see that update yet until you go ahead and calculate the animation. And it actually looks like you're pulling the band in there. Now I want to change the view that we're using on this. So I can go to any of the viewpoints that I have for orientation and view here, and I can go, maybe we'll make this a front view. So now I have a view of this thing kind of pulling back. Now this is how you can animate components that were built in context. You're physically utilizing the in-context relationships to be able to do that. Here's what it would look like in the end. Let's see this one here as an example. Okay, control how fast it comes back, how quickly it springs forward, and what the resulting motion is. Okay. Now, there are points in time where you want to simulate free motion. In other words, I don't want this thing to fly off here straight. I want it to fly off in some funky angle. Well, when I go to drag this component, if I use a move with triad, it's still got to solve the mates, which is a concentric with the shaft. So it won't let me pull it off at a funky angle. But what I'm capable of doing, and I talked about this a little bit earlier, is I could literally go to the mates for each of these components, and I could find the concentric mate that ties the two together. And for that concentric mate, at a certain point in time, let's say the 4-second mark, I can now suppress that concentric mate. Now if I scroll down the tree, you can see it's now created a key point where I've turned off that mate. And now what I can do is I can start to move that in a different way than what I would be able to before. So now I can do a move with triad. Let's just drag this out a little ways, and then I'm going to move it a little further, and I'm going to rotate it with the triad, and then I'm going to move it a little further, and I don't know, we'll just drag it out a little further. So I've just made this thing kind of do something completely different. But in order for me to do the free drag and capturing the free drag, I actually had to be able to drag it in these other directions, but with the mates I couldn't do that. So you need the ability to be able to turn off the mates to make that happen. Now, last example that I want to show before I show you where a lot of this is coming from. Let's see here. Make sure I get the right one. You can also animate springs the same way. So using a motor and in context springs that are created between two plates, the sketch actually adjusts itself as the plates move, and the springs actually look like they're moving. So even though we can't make things deform, we can utilize the ability to create in-context parts to make things look like they're animating. Now back to my PowerPoint for a moment. Some of you are already asking about this timeline. This is copied directly out of the help. Just go in the help and type in animation. You should be able to find it directly in there. Now, a lot of what I talked about today actually comes out of this book, and this is going to be my recommendation because there's no way I could possibly get through all the different variations of what's capable within the Animator product. But if you go to store.solidworks.com, there's a book called Creating Animations. I think it's like $65. I have it right in front of me. It's 575 pages that goes through everything, all the possibilities, all the ways of doing it. It's a step-by-step book to teach you how to learn animations. So I hope that today was useful for you. I hope that you have a better understanding of what it means to use animations within the motion study type.